But now what we're going to have to do to prove that they're congruent is we're going to have to write proofs. So we did a little bit of writing proofs before, if you'll remember, and then we got some problems that were way too hard, and I skipped them. Well, these are not quite as hard to prove. So we're going to have statements and reasons. So does anybody remember what my first reason is? Nope. My first reason is always what is given to me. I'm going to be given some information, and I'm going to write all that information down, and then the reason that I know it's true is because it's given. Do you remember doing that? Okay. So let's look at everything that they have told me about these triangles. They told me that segment TS was congruent to segment ZY. Right? They told me that by the tick marks. What else did they tell me?
S and R congruent.
They told me angle S and angle R were congruent because of the little tick mark. And what else? They told me side SR is congruent with side YX. Because look how they put the 2 tick marks on those. So they have told me 2 sides and the angle between them are congruent. That's just been given to me. Now, do I have enough to say these 2 triangles are congruent? Yes, I have enough because I have a side, angle, side, and a side, angle, side for both triangles. So what we're going to do then is we're going to name the 2 triangles, and we're going to then give the reason we know they're congruent. So what do we want to name the first triangle? Anybody? RST, I like it. We can pick any order we want for the first one. So let's name it triangle RST. Now we have to make sure we match them up with the second triangle. So when you look at R, we have to go from R to S. Right? So that means we're going along the side that has 2 tick marks, and we're ending with the one that's congruent. So from R to S, what does that look like in this triangle? X to Y. You see how I'm going down the side with 2 tick marks, and I'm ending in the side that's congruent. So I'm going to have to name this triangle X, Y, and then T corresponds with Z. So you have to make sure you match those up. And now I'm stating the 2 triangles are congruent. How do I know the 2 triangles are congruent? Because they have a side, an angle, and a side that they agree on. So on these proofs, our last reason is always going to be one of these things that we're going to make in our list. This is just one way we can prove triangles congruent, but we're going to discover several more as we continue. Okay, so right here is going to be a proof. We have Allie cuts 2 triangles from a rectangular piece of metal along the dashed lines to make earrings. How can Allie show that the earrings are the same size and the same shape? So we can see the rectangle that we're starting with, ABCD, is getting cut into 2 triangles. And I'm wanting to prove what? That those 2 triangles are congruent. They're the same size and the same shape. So what we're going to do then, let's draw out our 2 triangles. So the first triangle here, I have B to A to D, and I'm going to label it B, A, D. And then we also had here triangle B to C to D. Okay, so now what we're going to have to do is we're going to have to prove these two triangles are congruent. Well, right now we only have one way to prove it. That's going to be using side, angle, side. Right, so right here is going to be my statements and my reasons. Two-column proof. Statements, reasons. Okay, so what could we say about any of the sides using what we know about rectangles? What do we know about rectangles?
It has two different, like,
Congruent sides. They have they're
two separate congruent
Yeah.
sides.
The opposite sides are congruent, right? So we know that. And we also know, what about the angles of a rectangle? All of them are 90 degrees. Every angle is 90 degrees in a rectangle. So when I look here, look at side BA. What other side of my rectangle has to be congruent to BA? CD. So my first statement then I'm going to make is I'm going to say that segment BA is congruent to segment CD, DC. Doesn't matter. I'm going to go with DC. Now, how did I know that they were congruent?
Because it's rectangle.
Because why?
Because it's a rectangle.
Right. They are opposite sides of a rectangle. Okay, so I've got CD and AB are congruent. Check. Now again, if I'm going to have to use side, angle, side, what am I going to have to do? I'm going to have to know another side and an angle that I can prove are congruent.
ADBC.
AD and BC are congruent? How do we know?
Opposite sides of a rectangle.
They're opposite sides of a rectangle. So what I'm going to do then is I'm going to include this in that first statement, right? Because it has the exact same reason. So I'm going to say that you said AD is congruent to CB, which would be here and here. So right now I've got two sides are congruent, and the reason is the same. They're the opposite sides of a rectangle. So in order to use side, angle, side, and that's the only one we have so far, then I need that the angle between them to also be congruent.
9.
So angle A is 90, how do we know?
Rectangle.
Because it's an angle of a rectangle. And which angle would be between these two? Angle C, it is 90 degrees. How do we know? Because it's right angle of a rectangle. So we're going to say this. This is going to be my statement. I'm going to say angle C is equal to angle A, which is equal to 90 degrees. Right? I know they're all equal to 90 because they're the right angles. So these are angles of a rectangle. So that means I know that this is 90 degrees and this is 90 degrees. Now, do I have enough information to say these two triangles are congruent?
Yes.
Yes, I have side, angle, side. So I can say these two triangles are congruent to each other by side, angle, side. So our last statement is always stating the triangles are equal. So let's name this triangle. What do we want to name it?
Alfred.
No.
ABD.
ABD, that's fine. We'll go ABD. It's going to be congruent to. Now we have to make sure we match them up. A corresponds to which point in this triangle?
D. Or no, C.
A corresponds to C, right? They have the right angles in them. So A corresponds to C. Next is B. What does B correspond to?
CD.
So think about it. We were here, we were from A to C. If I go A to B, I went across the blue side, right? So that's going to be C to
D.
D. Because that also goes across the blue side. You see how they correspond? So we're going A, B, D is going to be C, D, B. And again, the way you name them, you have to be careful. That's the part that you can miss very simply. And how did we know that these two triangles were congruent? By side, angle, side. We proved they had two sides and the included angle congruent. Therefore, we know that these triangles have to be
Let's
congruent.
just call it SAS.
Okay, here, what are we given? We're given that AB is parallel to CD. So they have that marked for us here. AB and CD are parallel. And we know that AB is congruent to CD. How do we know? Because they told us. Okay? We're wanting to show in the end that angle B is congruent to angle D. So this one's a little bit different. Okay, but it's still the same basic principle. So we're going to make our two-column proof. We've got statements and reasons. Okay, so on this one, my first statement, I'm going to say I know AB is parallel to CD and AB is congruent to CD. How do I know those things? Because they're given to us.
A given.
So this time we have a given as our first reason. Right? Most of the time you will have a given as your first reason. Okay? So let's think about what else we have. So we know these two sides are congruent, and we really know nothing else besides these parallel lines. So how could we use those parallel lines? Well, what did we do in a whole section with parallel lines?
Transversal.
If I have two parallel lines cut by a transversal, right? Two parallel lines cut by a transversal. What do I know? I know that I have alternate interior angles that are congruent. And those will be the inside angles of my triangles. So those are what I care about because they're parts of the triangle, which is what we are working with. So we could say then that this angle and this angle have to be congruent because they are alternate interior angles. So let me clear this off a little bit. Now I think it's a little bit easier once I draw it. We can say that this angle and this angle have to be congruent. So let's name them. Angle BAC is congruent to angle DCA. And how do I know that? Because they were alternate interior angles. Okay, so let's think about it. Again, right now we only have one way to prove triangles congruent. So what do we have? We have a side. We have an angle. So I need to find that this side is congruent. So I need to say that CA is congruent to AC. Well, are they the same length?
Yes.
How do you know? Because it's the same line, right? It's overlapping. So what we can do then, we can say that CA is congruent to AC, and this is called the reflexive property. Because it's literally a reflection of itself. right? From CA to AC. So if I know CA and AC are congruent, do I have enough information to say the entire triangles are congruent?
Yes.
I do. I have side, angle, side. So let's go ahead and name the triangles and say they're congruent. So somebody name the first triangle for me.
ADC.
ADC. Thank you for not saying Bob or something. I mean, we heard enough of that. Okay, so if I go from A to D to C, which angle corresponds to A in the other triangle?
B.
C,
Confusing, right? So let's talk about this. We're going from A to D.
C,
Do we have any drawings on A to D?
no.
I have none. So which triangle do I have no drawings on over here? Which part? C to B. So A has to line up with C. Right? That way I can go here, then I can go across the ones, then I can have the angle, and then I can cross the two. So A corresponds to C. D corresponds to B, and C corresponds with A. And the reason I know is because of side, angle, side. SAS. Now, here is the new part of this one. Okay, so this one has a little bit of a new ending. Does this tell me to prove that the two triangles are congruent?
No.
No. It tells me to prove angle B is congruent to angle D. Well, do I know that they are congruent? Well, I do now because I know the entire triangles are congruent. So I know that AD is congruent to BC. I know that this angle has to be congruent with this angle. And I know this angle and this angle. Because the triangles are exactly the same. I proved they were congruent. So what we're going to do, because I'm having to prove a specific part of the triangles is congruent to the other part, then once I prove the triangle's congruent, I can state that angle B is congruent to angle D. And the reason is congruent parts of congruent triangles are congruent. CP, CTC, which stands for congruent parts of congruent triangles are congruent. Which again, makes sense if you think about it. They're the congruent parts of the congruent triangles, therefore they have to be congruent. Because think about it. B and D, look where they line up. B and D, they're in the same position because they are congruent. They're congruent parts of congruent triangles. Therefore those parts have to be congruent. Okay? Here's the second way that we can prove triangles congruent. First, we looked at side, angle, side congruence. Next, we're going to look at side, side, side congruence. If I can prove all three sides are congruent to another triangle with the same three sides, then the triangles have to be congruent. Side, side, side congruence.
That entire first.
Right, the givens. It tells me AB is congruent to DE. It tells me BC is congruent to EF. And it tells me AC is congruent to DF. The reason is it's given to me. So look, they've already drawn all these on here for me. AB congruent to DE. So they've got the one tick mark. Then we've got BC congruent to EF. That's the second tick mark. And then AC and DF. They're the 3 tick marks. So do I have enough to say the triangles are congruent?
Yes.
Yes, I do. I can say triangle ABC is congruent to triangle DEF. And what's my reason? How can I say that the two are equal? Remember, if I'm saying the 2 triangles are equal, I have to use one of these from this list we're making. Do I know side, angle, side?
Yes.
No.
Side, side, side.
I know nothing about any of the angles, right?
You know,
So my reason can't
Oh,
be
yeah.
side, angle, side. This time I only have the 3 sides congruent. So my reason here is going to be side, side, side. Because that's what I'm given. Everybody agree? Side, side, side? That is correct. We could use side, side, side on that one. What about the second one, the one beside it?
Side, sass. Fan for fan.
Yes, that one there we can use side, angle, side. All right, what about this one?
Not
Fan.
determined.
What? Oh. Yeah, not
In order to use side, angle, side, what has to happen? The angle has to be,
the same.
and it has to be between the 2 sides. You see how here my known angle is not between the 2 known sides. So I can't use side, angle, side. Right, what is this? This is angle, side, side. And we don't write that down, okay? So side, angle, side has to be the abbreviation. That one doesn't work. So this one, no, doesn't work. Can't do it. What about the fourth one?
Sass.
That one we do have the included angle, right? So side, angle, side will work with that one. Now look at B part. It says, hey, I want to prove these 2 triangles congruent using either side, angle, side or side, side, side. What else do you need to know in order to say that these 2 are congruent?
For SAS, AC is congruent to DF, and for SSS, AC
Okay,
is congruent to
So
DF.
to get side, 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 we'd have to have 2 pieces of information, right? So because we already know an angle, then all I need is the other side to make that an included angle. So that's what we want to say. We would say that we need segment AC to be congruent to segment DF. And if we knew that information, then we could say that they were congruent.